So welcome all to my YouTube channel. So today our topic is dependent sources and solving the questions which have dependent sources using KVL and KCL techniques. So first of all, what is a dependent source? We till now have seen voltage source, DC voltage source like this, and current source like this. Correct? So we always have a fixed value of this. Suppose which is 3 volts, or this is suppose 5 amperes of current, or something I amperes, or this is V volts. Okay, so we always have the definite value which is not changing with any other value of the circuit, or which is not dependent on any other value of the circuit. Okay, so now we will be learning about the dependent sources. So the way to simplify dependent sources is like this. We use this diamond shaped signal to represent this type of sources are known as dependent source. If we use a source like this, these are called as dependent source. Dependent source. Now it could be of many types, 4 types. Okay, so 4 types. So suppose this is a voltage source. Suppose this is a voltage source, so minus plus is indicated, and suppose this is a dependent current source, then like this it will be current, this will be indicated, and arrow will be there if it is a dependent current source, and plus minus will be provided if this is a dependent voltage source. So 2 cases of this, okay, and 2 cases of current source. So the 4 cases are current controlled current source. Okay, current controlled current source. Okay, you can exhibit. I just writing the short form. The second case is current controlled voltage source. The third case is voltage controlled voltage source, and the fourth case is voltage controlled current source. So here we have 2 cases of current source. See this one, current controlled current source and voltage controlled current source, and we have 2 cases of voltage sources, current controlled voltage source and voltage controlled voltage source. So what is the meaning of these things? Okay, so suppose this value of this is a voltage source, so these 2 cases are implemented, these 2 cases can be implemented, these 2, okay, these 2 are voltage sources. So if the value of this battery depends on some value of current in other part of the circuit, suppose this is 4I1, so this is a current controlled voltage source. This is a current controlled voltage source, and suppose the value of this potential depends on some other potential at the circuit, some other unknown value of potential, suppose 4V Vs, this potential is not known to me, then this is known as voltage controlled voltage source. If the voltage source is depend on current at any part of the circuit, then it is a current controlled voltage source, and it is dependent on voltage at any part of the circuit, then this is as voltage controlled voltage source. Similarly, if this value depend on current, this I is suppose any current at any mesh or any loop. Okay, so this is current controlled current source as of now, and if this depends on voltage Vs at any point, suppose this is V1, this is any part of the circuit, it depends on the voltage, then this is known as voltage controlled current source. Okay, so these are the cases. So these are the cases. Okay, current controlled current source, when the current source is dependent on a current at any part of the circuit, it is current controlled current source. When the voltage source is dependent on a current at any branch of the circuit, it is current controlled voltage source. When a voltage source is dependent at a potential at any branch of any 2 points of a circuit, then it is a voltage controlled voltage source. And if the current source is dependent on voltage at any part of the circuit, it is known as voltage controlled current source. Okay, so we have examples. We will look at the examples. You will easily identify the same because with the help of example. So here we have a source. it is a current source. So first write this is a current source. Correct? This is a current source. Arrow is there, so it's current. So the value of the current is given as 4V. It is not the potential difference. It is the 4V magnitude of current flowing in this branch. Okay. So the magnitude of the current is depending on the voltage. So it is a voltage controlled current source. It's a current source, but it depends on a voltage. What voltage? This voltage is this V. The potential at this point is V. So this current is depending on this potential. So this is VCCS. So now let's look at this. This is a voltage source. This is a voltage source. Why voltage source? Because plus minus is given. So it's a voltage source, but depending on a current. Which current? This current at the circuit. So it is dependent on some current at which is present at the circuit, but it's a voltage source. So it's a current controlled voltage source. So now look at this. This is a current source depending on a voltage. So voltage controlled current source. What is this? Where is this voltage? This voltage is this across this resistance, across this 5 ohm resistance. Okay. So this is the voltage. Okay. So this is the this is dependent on voltage. So voltage controlled current source. This is the voltage controlled current source. Okay. And in this case we can see it's a current source. It's a current source, but it is depending on current. Which current? This current at the circuit. Okay. At this mesh current. Okay. So this is a current controlled current source. Now it's clear. So we have dependent sources, dependent DC sources, which depends either current or voltage from the same circuit. Okay. So this is known as controlled sources or dependent sources. So now we will solve these 4 problems to know this better. Okay. So to learn this better. So the first question is of a voltage controlled current source. Okay. So look, let's draw the diagram over here. So we can see that it has a current source which depends on a voltage V. So we will just to solve all the dependent source problems, we will just use KVL and KCL only. But first we need to find the variable in which the sources are dependent. That's after we will able to solve the complete circuit. Okay. So first we need to find out the voltage here, because this current source is depending on the voltage. So when I will know this V, then I can say what is I1, this what is I2, what is potential drop across 6 ohm resistance. Okay, I will able to answer all the questions. But first I want to know the variable V. Okay. So to solve this question, we can see 2 current sources are present over here. This is also a current source of 2 ampere, and this is also a current source which depends on this value V, 4V. So the 4V current is flowing over there. Okay. So since both the sources are current sources, KCL is preferred. Okay. So I will use KCL. Okay. So KCL, applying KCL at node this, suppose this is node 1, at node 1. So what is the statement of KCL? Summation of incoming current is equal to outgoing currents. So let us assume the currents first. Okay. So from here you can say this is this is 2 amperes coming, because here is a current source, so it is maintaining a 2 ampere current across this branch. Here I1 is going, okay. So what will be, suppose I assume the current to be like this, okay. So what will be this current? What will be this current? This is incoming, this is incoming, okay. So this current will be nothing but, let's suppose this current to be x, suppose for a second, okay. So x plus 2 equal to I1, because this is coming towards this point, this is coming towards this point. So summation of inward current x plus 2 equal to summation of outgoing current from the node, okay. So the x will be I1 minus 2 amperes. So this current is nothing but I1 minus 2 at this direction, okay. One more current is present, I2, okay. So if and one current is coming towards this, okay, 4V. This is not a voltage, this is a dependent source. So this is a current source, okay, but the value of the current depends on V, okay. So at applying KCL at this point, so I assume this current to be going, this current is also going, and this current is incoming, this dependent source current is incoming. So incoming current, let's write 4V equal to outgoing current, that is I2 plus I1 minus 2, correct. Now how I can write I2? The potential at this point is V and this is 0, so for my simplicity I assume that point to be ground, okay. So V minus 0 upon 6, okay. So 4V equal to I2 will be V upon 6, V upon 6 plus what is I1? This is V, so this point will be also V because there is no resistance, full point is V and this is 0 only, okay, same ground connected. So V minus 0 by 3, so I1 will be V by 3 minus 2. So from this equation we can easily calculate the value of V. So this will be nothing but 4V equal to 3V by 6 minus 2 equal, implies that 4V will be equal to V by 2 minus 2. So implies that V by 2 minus 4V, V by 2 minus 4V equal to 2, which will be implying minus 7 by 2V equal to 2. So V will be equal to minus 4 by 7. So value of the V will be minus 4 by 7, okay. So now when I know the value of to be minus 4 by 7 volt, so I came to know this, okay. 4V equal to I2 plus I1 minus 2 using KCL at this point. So I2 I can write V by 6, V upon 6, okay, and I1 I can write as V upon 3 minus 2. So this current is I minus 2, okay. So 4V equal to V by 6 plus V by 3 minus 2. So it will be, by taking LCMs, it will be 3V by 2, V by 2, and when I solve these two equations, if I take it there and 2 over here, so it will be minus 7 by 2 V equal to 2. So V will be equal to minus 4 by 7. So now I can solve every question. So what is the current, total current? It will be minus 16 by 7. The source current will be, it is 4V, so minus 16 by 7. Source current will be, source I will be minus 16 by 7. So now I can solve, when I know the V, I can also find out the I1, I can also find out the I2, because I1 will be equal to nothing but V by 3 equal to minus 4 by 21, okay. So I2 will be nothing but V by 6, okay. So V is nothing but minus 4 by 7 into 6, okay. So we can solve all the things if we find like that. So what we have to approach the dependent current source problems, we will just use KCL and KVL only, but first we will find out the variable in which the dependent source is depending, okay. So in this case, it was a current source depending on voltage. So we find out the voltage first. Now let's look at the next problem. So looking at the next problem, it is a case of current controlled voltage source. Current controlled voltage source. So the question is V across 1 ohm resistance, okay? V across 1 ohm resistances, okay? So both are 1 ohm resistance, so we need to find the voltage across these two resistances, okay? So this we need to find out, okay? Which will be equal to IR, okay? So I we have to find out into 1, that is resistance, okay? So now looking at the problem, we are seeing that here we have a dependent source. The dependent source is a potential source, that is a voltage source, okay? Plus minus is a voltage source. But the value of the voltage source is depending on a current. Which current? This mesh current. Okay, this loop current. So the potential is depending on the loop current. So we will find out the I first. So using KVL, we will write I minus 3I, because this is not a current, okay? This is the potential drop itself. This is not a current source, but the value of the potential is in terms of current, that's it. So it's a current potential drop only. 3I is the value of the potential drop, not the current. So don't panic about that. So this will be 3I1, I minus 3I1, again plus I minus 30 equal to 0. So upon solving 2I minus 3I minus 30 equal to 0. Upon solving easily, minus I equal to 30. I equal to minus 30. So assumption of my direction of the current is wrong, but the magnitude of the current is 30. So if I ask you what is the potential across from this point to this point at this resistance, it will be I into 1, because I add from this point to this point, what I have to assume this direction, okay? So in this direction minus 30 is flowing, at this direction minus 30 is flowing, but in this direction plus 30 current is flowing, okay? If I say the current direction I assume to be this, so I have to use a negative one, and if I assume to be the opposite, then I can use plus 1. So nothing but it is minus 30 the current is flowing, so minus 30 volts, okay? So here if I say, if suppose here if I say what is the potential drop at this point, okay? So it will be nothing but again minus 30 volts, okay? So like that we can solve. So the potential drops are from this point to this point is minus 30s, okay? Minus 30 drop is here. So what will be the total drop from this point to this point? If I ask, it will be minus 30 into 3, so it will be minus 90, okay? But already a minus sign is also there, okay? So minus, if I go like that, it's minus 90 first, then the sign also to calculate. So this here, it's from this point to this point, the drop is minus 30. So if I write the KVL now, so drop here is minus 30, drop here is minus 90, but of a negative sign, so minus of minus 90, and again minus 30, and again minus 30 of this battery. So KVL proved equal to 0. So minus 30 is minus 30, so it will be minus 90 plus 90 equal to 0, okay? So like that we can solve each problem. So there we are having a current source, so here we were having a potential source, voltage source, whose value was dependent on the current. So we find out the current first, then solve the problem. And why I do this all stuff is to make you familiar with the direction of the current. You just got the direction wrong. If you get a minus in the answer, that means that I assume the current to be like this, but it's flowing like this. But if I assume to be like that only, that my initial direction is correct only, then I have to use the minus everywhere. That's it, nothing, no problem. And if I ask this point to this point, the drop from this A to B, so I have to go from A to B. Okay, so either direction of the current I can choose, but I have to use the same convention of the sign also. If I choose the current is flowing like this, so I have to use minus 30. If I assume the current is flowing like this, I rectified my direction, then I have to use plus 30. That's it. It's your choice what to follow, but whatever you will follow, you have to use the sign convention. Very, very important. Okay, solving problems will make you understand these things. Okay, so case 3 is of a voltage controlled current source. So we have a question. Question is to find V1. Okay, in this question you will understand why the signs are so important. Also to find I2. These are the questions. Okay. So this is a case of a current source. Okay, we have an arrow, so it's a current source. The value of the current source is depending solely upon the V1. V1 is a potential. Where the potential? Where is the V1? It's not updated yet, it's here. So the potential across this 5 ohm resistance is V1, and the current source is depending on this V1. So first of all, to solve any question, we have to solve the value of the dependence. Okay, so that is the V1 over here. So applying KVL. So what if I apply KVL over this circuit? Starting from this point, it's minus 8. So it's 5I1 plus 5I1. Okay, I don't want to include more variables over here. Okay, so first I will write it at terms of IR. I will not use plus V1. Okay, although this is the same potential, but why I would like to include more variables to my question. So I will just use IR. Okay, this is the IR is same as the V1. Okay, plus 4. So from starting from here, minus 8 plus 5 into I1 plus 4 equal to 0. So value of I1 will be equal to minus 4 plus 8 upon 5. Minus 4 plus 8 upon 5, which will be equal to 4 by 5. So this is the amperes. So I find out the value of I1. So what I need actually is the value of V1. Okay. So V1 is nothing but I into 5. I1 into 5. So what is the value of I1 I got? 4 by 5. So 4 by 5 into 5. So it will be 4 volts. So now I know V1. So I know the value of V1. It's 4 volt. It's 4 volt. So now I know how much current is flowing through this circuit. Okay. So it's 10 into V1. That is 40 amperes. So 10 V1, the current of I of source of the dependent source is equal to 10 into 4 equal to 40 amperes. Okay. So the 40 ampere current is flowing like this. because it's already mentioned it's a current source, so it's maintaining a current at this direction. Okay, so 40 ampere is flowing. Now also I want to know I2. What will be I2? I assume the loop current to be like this. If I suppose I am telling 40 ampere is going downwards, the I2 is the same thing but in the opposite direction. I2, the current is same, 40 ampere current is present in this full loop. No other current is present because the current is in a single mesh, the current is constant. Okay, the mesh current cannot change. So this is only 40 ampere current is flowing because the current source is here over here. In our earlier lectures we already talked about it. Okay, so what's the thing is that, so if I say 40 ampere is going down, so I2 is in the upside, so I will just write minus 40 amperes. If downside I said that 40 plus, then the opposite side I will say minus 40. So I2 is minus 40 amperes. Okay. Similarly, we will solve next question. So if you are getting complicated over here, I will just tell you it is a same road is there. Okay, I am just telling. I am just telling this is the road is same. Okay, suppose some current is flowing this y, this is a y. Okay, some current is flowing 40 amperes from A to B. Okay, I can say same thing, that it is as same as 40 ampere. If it is A to B, it's flowing. So if I say from B to A minus 40 is flowing, same thing. Suppose I say from A to B 40 ampere is going, so this direction I took in as plus. Okay, so that direction will go. Cases we will see the last fourth case. So in the fourth case, it is a current controlled current source. Okay, it's a current controlled current source. So let's work. Source, current source. It is a current controlled current source, so it must depend on current at any point. So this is I1. So this is also, this is 0.4. Something is alright. So okay, first of all, I change the value. You can look here in the example is 100 and it's written over there, but I change the values of the resistance to solve the problem. Why so? You can comment in the box. You can comment in the box why I change the values. Or otherwise none of the subjects change the value of the problem. But in this case, I changed the values of the problem because there was 100 and but why? You can comment me, so I can know that. Okay. So let's see how to solve this one. So as all previous cases, we will have to solve what the dependence value I1. First I have to find I1, then I can know the value of this 0.4 I1. Okay. So using KVL, so here 0.4 I1 is flowing from here, 0.4 I1 is flowing from here, I1 is flowing. Okay, and it is 300. So 300 I1, just using KVL at 1, 300 I1 plus 500 I1. Downside I am assuming this to be positive, this direction. So downside I am coming from this point to this point. So here I1 is flowing, and in the opposite direction 0.4 I1 is flowing, minus 0.4 I1. Now coming to this one, minus 50. So I can say 300 I1 plus 500. Otherwise I can write 0.6. This will be 0.6. Okay. So it will be just 0.6. So it will be 300 I1 AM minus 50 equal to 0. This is 300, this is 500 I1 minus 0.4 I1. So this is 0.6 and 0.6 into 500 is will be equal to 300 only. So 600 I1 equal to 50. So I1 is nothing but 5 by 60 or 1 by 12. So once we know the value of I1, I can easily say what is the source current. Source current 0.4 by 12 amperes. So what is the voltage across this point? I1 into 3 ampere. So I can actually solve any problem if I know the value of I1. So this was a case of current controlled current source. So what we learned is that first we have to use the basic techniques KVL, KCL only. First we have to find what is the value in which the source is being dependent. Okay. So the finding the value, this value will easily let us solve all the problems. Okay. So this is nothing tough. This is very easy. So we have to just look and not like that this is a current source. If suppose it was a voltage controlled current source, I have to still treat this as a current source only. The value is just depending on the voltage at some point of the circuit. Okay, so I have to check the source and just I have to work accordingly. Okay, and easily we can find out. Okay, just finding the unknown dependence will solve the full question. Okay, so first analysis which type of sources it is, which way you want to go, KVL, KCL, which loop first, and you can solve. This is nothing but same KVL, KCL, but with some dependent sources. Okay. So this was all about dependent sources. So we will be going to the network theorems next up, and after the network theorems we will solve more and more questions, difficult, easy, lots of questions. So thanks for watching.